Today we are going to explore a bit of basic web scraping using Julia. Web scraping is a way to collect data that is relevant to us from public websites. This type of data collection could be quite troublesome if carried out manually or even impossible. Thus, web scraping collects information automatically. Usually, the data available on the web is designed to be accessed by humans with intuitive interfaces and graphics that allow for the user to quickly obtain the information that he or she needs. This is not the case for a web scraping application that needs to access the raw data of the web page and filter the relevant information without caring about its graphical interface. These types of applications are usually done to save data over a long time for further analysis. Maybe you are interested in following a product price, or you want to quickly know if there was something new published about a theme that you want to follow. This type of analysis will then need to be done periodically. Now, as I have told you before, usually a web page is designed to interface with a human, and all of those components that allow for the website to do it are going to be present when you access the web page, even though you are only interested in analyzing text. When you access a web page, the server sends to you HTML data to be displayed on usually your browser. In the case that you are using a web scraping tool, this data will be stored as text for your program to later interpret, analyze, and filter. Once the HTML data is available, we can then extract useful information from it. If you are tracking, for example, the price of housing, you try to find a keyword for example, the price or the currency symbol used. If you want to search for news on a certain topic in a newspaper, you try to find, for example, delimiters that could be defining the titles of each article on the web page, or just simply try to find the word of the topic that you are searching for. It is important that the method that you have found to collect the data is stable over time, as usually the intention of this type of applications is to gather data over a certain period. So you want to be sure that the limiters that you have found or keywords will always be present on the web page. Once you have identified the data and collected, you should store it in a database. It could be as simple as a CSV file that you can open on Microsoft Excel, or it could be an SQL database. Okay, so up next we are going to see how to code the web scraping example in Julia. So let's now create a file here on Julia, on our editor, Visual Studio Code, and we select as a language Julia. And what we are going to do now is create here a code that is going to access a website, and with all the HTML information that we are going to obtain from that website, we are going to filter that information and extract only the data that we want. So I like to do the code like this, where I put chapters and subchapters, and our site is going to be our variable here. Site is going to be the guardian.com world. I'm going to show you guys the web page in a minute, but right now we are going just to write the code to obtain the HTTP information from our website. I'm going to use here the http.request, and we are going to ask for a get to that website. The HTTP requires the library. That's why I'm using here the using HTTP. And as you can see from our output, we got not only the HTTP, but a overhead here. We got the 200, okay, means that all the data was gathered successfully, but the HTML is here. It's on the bottom. It's the body that we want to extract. So in order to do that, we need to get that R1 body. So our HTTP string is then going to be the R1.body. But as you can see, we got a byte here. It's the uint8. It means that every information here is on byte, and I need to extract the string from those bytes. That's why I'm using the function string. The S here needs to be in uppercase. And yeah, we got then our HTML. We only got a preview here on the terminal from Visual Studio Code. So what we can do to check all the HTML is to write all that information in a file. I'm going to use here the function open in order for us to have our file to write. It's going to be called output.txt. and it's going to have write permissions. So what we are going to do now, and we are able to do, is write on that F1, the file, our HTTP string. So everything should be here on the output txt. You can see that the file appears here on the left. And inside of all of that HTTP data, it's going to be our information that we want to obtain. So I need to filter that data. I need to search for a certain keyword that is relevant to me. So here on the second chapter, I'm going to search for the information that I want. And in order to do that, I need to have a pointer that points me to the information that I need to find. So I'm going to search here for a keyword. It's going to be a hot topic right now, that is Russia. So this is my search string. And you can see here on the HTML, if I do a search, I can see a couple of news here. And this is what I want to detect. This reference seems to be very good here. And you can see on the web page that all of the news are going to appear here as a graphical interface, of course, but it's something that is going to be as well represented on the HTML data. So you can see that there is some news that are going to be repeated. So it's something to be aware of somewhere in the middle of the code. The location, we can then search for it by using the function find all. It's going to find all the positions where my keyword is. And yeah, I need to search then on the HTTP string. So if I run this, it's going to give me actually a vector. You can see that is a vector of ranges, which means that it's not going to point directly to the first position of the keyword, but it's going to give me the positions of all the chars from that keyword. So you can see that I got 6 positions for every keyword that was found. That is 44 keywords. And now what I can do is go over to that array, to the HTTP string array, go to my first position, and using the first character as a reference, I'm going to search for 100 characters before and 100 characters after. And you can see that I got all the information here together with my keyword. That is the same information that I got from my output txt. So from my search location vector of ranges, I actually need only the first position of those ranges. So what I'm going to do here, just extract the first position from those ranges. So my search location, I am going to get just the first one for I equal to the length of my search location. And you can see that our for loops here on Julia can be in a single line. And the value obtained, it's actually the same. We can compare the both. So it seems to be working. Another option would be not to use the for loop, but something else. I'm going to show you here, as we've seen before, we could treat these ranges as a matrix. So in order to do that, we can use the function horizontal concatenation and the 3 points. That is, for me, in order to create an extension of that range to have actually values. So you can see here that in the end, it's actually a matrix of values and not a vector of ranges. So I can now use just the first position of all of those ranges. So as you can see, I can run the code here and it's going to give us the same output. Now, as I have the first position of all of our keywords, I can now search for the string around that keyword. So our interval around each keyword is going to be 150 chars. So I'm going now to create substrings around those keywords. To do that, I'm going to use the function range applied with broadcast. You can see here from the point. And yeah, it's going now to create this interval, search pointer minus the interval, also broadcast, plus the interval. So it's going to be 150 chars before the pointer and after the pointer, applied to all the pointers. Then with these intervals, with this vector of intervals, I can then extract substrings from the original HTML string. In order for us to do that, we are going to use this substring function that can extract a range from a specific string. And we can do this with vectors. So we will use our substring intervals as a vector and apply those to our HTTP string. So let's run this function here. And you can see that now we got a 44 element vector of the type substring with all the information around our keywords. If we don't want our substring format, we can use just the string, apply it with the broadcast to all of these vectors, and instead of a substring, we are going to have just the string. This is easier for us to do some applications here. One of those is going to be the split function. So I'm getting 150 shards before my keyword and after my keyword. But what's really relevant to me from this information that is all around my keywords? So from the string array number 1, you can see that this data ID has a lot of information here. From the second one, you can see that we got a link, ahref, that is also packed with a lot of information. So I can use this hypertext reference tag from HTTP to be my keyword for splitting. So what I'm going to do here is then use this keyword to split all of my substrings. And you can see here that the output, it's going to be a 2-element vector if the keyword exists, or if it doesn't, it's just 1. Now, we can now use this difference in terms of size to determine if a substring has that keyword, our hypertext reference, or it doesn't. So I'm just going to search my relevant substrings as being the ones that have a size of 2. And you can see that the output of this function size is either 0 or 1, depending if it is equal or not to 2. And I'm going to use this variable relevant as a mask for this array number 1 that is going to filter my substrings and select only the ones that have this hypertext reference. And of course, if we sum all the values from my mask is either 0 or 1, we are going to have the same value that we got in terms of size for our relevant string, that is 23. So this leaves us only with the relevant substrings that we were able to filter by having a hyperlink or not. And what we are going to do is just select the second column. The second column is the one that has the link, and that link has tons of information. It's actually the information that we want. Let us see what is inside. For that, I'm going to pick up the first substring. And as you can see here, we got the theme, that is world, the year, month, day, and then the news itself. So we know when the link starts, but actually we don't know when the link ends. For that, I'm going to use this function, find first. You can see it here on the help. This function will search for a string on our substrings. So I'm going to use it to search for a backslash that will end my link. And we'll use this char as our search string. Inside, of course, our relevant string 2. So we can go ahead and click it. Once again, it's a vector of ranges. In this case, it is only one char. It starts and ends with the same pointer, with the same value. So now, the same as before, hcat and the 3 points to transform this range to a matrix. And we are going to subtract 1. The compiler is actually giving an error right now, just because, yeah, we are subtracting a scalar with a vector. So we need to use the broadcast function. But after using this broadcast function, then it's good to go. So what we got now is actually the end pointer for our string. We have calculated that to be before that backslash. So what we can do now is to check the string in order to see what is the information that I want to retain from here. And yeah, there is a couple of overhead here that's always going to be the same. That is the website itself, theguardian.com/world, and we can remove this because it's always going to be the same. I'm only interested in what comes next. So yeah, it's 34 chars that we can remove, so we can start on a 35 till the end of the string that we have detected before. So now we have a beginning and we have an end. Let's do this for loop for all of our relevant substrings. So using this, then we are able to extract only the link itself and the part of the link that is actually relevant to us. So as you can see here, we got 21 of those, and the first one, second one, third one, they have pretty much the same behavior, except this third one. This third one has that live in the beginning of the string. So yeah, what's happening here is that the different strings have a different amount of slashes. Another thing that I should also remove here is repetitions. So what I'm going to do here is just use the unique function that is going to allow me to delete from my vector strings that are going to be repeated. So this is important. Let us check. So all of those strings that we have before can be filtered in only 9 unique strings. So yeah, now we have these 9 pieces of news with the dates, some characteristics of it, if it is live or if it is just an article. So what we can do next is using this part of the links to create a table with all the information that we can obtain from these strings. So I'm going to split these strings based on the slash. So you can see that all the information is separated by slashes. So yeah, I'm going just to use the slash here in order to split. And what you can see here is then I create a vector of strings. So I'm actually now noticing an issue here, that is one char is missing on the end. And if I repeat again, it's going to disappear again. Okay, I think I know what the issue is. Let me just try again. Okay, now it's working. The issue was that I was repeating the line 33 2 times. I have repeated it on a terminal. And yeah, it was just removing the last char. So another thing here that I need to remove is the last line. It's a little bit of an outlier. So in order to do this, what I'm going to do is just remove the last line and give it again to the variable data table, solving then the issue. And now what I'm going to do is, so I know that every line has a different amount of columns just because of that live column that is very specific from line 2 and line 4. So the ones from articles have 4 columns and the ones with live have 5 columns. So I need to compensate this. In order to do that, I'm going to create a for loop for all the lines. And if that specific line, if the size of the data table on that line is equal to 4, then I need to add an extra column. And that extra column, what I'm going to write there is just, it's going to be an article. So we got the live web pages, where I think it's a kind of an article that is updated in real time. And then we got just normal static articles. So yeah, what I'm going to do is then create this article, and then I'm going to end the if and end the for. Let's run this code, see if it works. Okay, it's giving an error here. And that error seems to be, seems to be on the size. We are missing a parenthesis here. Okay, let's run again. Okay, it has now run. Didn't print anything, so I'll just put a variable here, and it seems fine. So every single line now has 1, 2, 3, 4, 5 columns. Still on this loop, what I'm going to do now is on the title of the article, we still have those hyphens, so let's replace those. So on data table I5, that is the number of the column, I'm going to replace. And I'm going to replace the hyphen with just a space. You can check the function here. So the replace function, we can just give the old and the new string. In this case, is only a char. So the hyphen is the old one, and the new one is going to be a space. So I'm going to use a space here that is going to substitute my iPhone. Okay, so this should work. I can run it and check the variable again. And yeah, of course, we have changed the last column, and everything that was an iPhone, it's now a space as expected. And what we got here is actually a table with the current information that I can gather from the website. Of course, we can do this for several days, and every day it's going to have different news, but we need then a way to store this data. I'm going to store the data as an Excel file, so I'll be using here the library delimited files, and I'm going to use the function write_dlma. This function will write a matrix, a vector, on the file separated by our delimiter. So I'm going to use here the function, and I'm going to create this file, this data CSV, comma separated values, that is going to host all of my data that is coming from my data table, separated by commas. And as you can see, I have just created this data CSV that I'm going to open with Excel. So I can just go over my Excel, create a new workbook, and then on data from text, comma separated value, CSV, and I'm going to select the file that was outputted by Julia. And as you can see, I got the table here. I have just imported to my Excel file, and yeah, we got everything here. Thus finishing our tutorial. I hope it was informative, and we'll meet again on the next one.